Okay, so yesterday we did the circle, right? So that was perpendicular to the base, and it gives us a circle. So to get a parabola, we're going to cut parallel to a side. And when I cut parallel to a side, I get a parabola. All right? So besides the fact that you've seen the parabolas like with sports, when we throw a baseball, when we throw a football, those are parabolas, okay? There are also many real life, okay, so Isaac, you were saying you've been to St. Louis, right? You've seen the arches. It's a famous example of a parabola. Okay, we said the Eiffel Tower was a parabola. Look, McDonald's. Me too. And in first period when that came up, I was like, oh, yum. Oh. Okay. You went to the Coliseum? That would be cool to see.
I want to go to Greece.
Yeah, that would be really cool to see.
I'm going to go to Greece.
Okay. So, yes. Yes. Okay. So, I do want to show you. Oops. Okay. Okay, listen. So the reason we do parabolas is because parabolas have a focal point. And the reason they have a focal point is because that reason that we use them, for instance, when you see a satellite dish. Okay, guys, anything that comes in parallel and hits the parabola is focused at the focal point. And so with a receiver, that's how we can hear, but it also works with a flashlight. And so do not go to sleep when I turn the lights on. Nobody go to sleep. It's not an instantaneous thing. So look. So the flashlight, that's how it actually, so it focuses in one place, and it comes, that's how it works. Wake up, Cardarius. I knew you were going to sleep. Who else has their head down? Wake up. Okay. Okay. For this? No. So there's not going to be anything to memorize because you're gonna know it. It's easy. All right. All right. So listen. We have two kinds of parabolas. So if it's the x squared, that's the up and down. That's what we normally do in Algebra 2. These are the ones we normally do. And so the x is squared. But we also, if the y is squared, it can go right and left. Okay? So nothing is changed at all. You didn't have to, nothing I'm going to do today is new. So. Have we written any notes yet? No. But now we're going to. So this is going to go with the up and down, and this one is going to go with the right and the left. Okay, so for the up and down, the vertexes H and K. The axis of symmetry always comes from the x variable. What? Okay, the focus, which I'll explain in a second, is H and K plus P. And the directrix is Y equals K minus P. And the focal chord is the absolute value of 4p. Yes.
That looked like a V. No, it doesn't say I know I just see what it would do. The best hot pocket is ham and cheese.
Yes.
Oh, no, those are so nasty.
You're nasty.
I like them plain.
Pepperoni sauce. Wait, go back.
Okay. I know, but we're talking about Hot Pockets, so I assume you have it all. Then zip it.
See, yeah, I can see it.
Okay. Zip it.
He said we trying to find out parabola of the hot pocket. Because you know when you cook the hot pocket, it go in. So it go out too. So it's the hot pocket.
Okay. So, first of all, given this equation, so I have x squared plus 10x plus 16y minus 7. So it's not a circle, because if it was a circle, it would have the x squared and the y squared. But this only has the x squared. So I'm going to complete the square just with the x squared. If it's x squared, that tells me it's a parabola, and it tells me it's either up or down. So this, I'm going to complete the square. So I'm going to move the 16y to the other side and add the 7. So when I complete the square, this is your b over 2 squared step. So I'm going to add 25. So I'm going to add 25 over here. So then when I write it as a perfect square, okay. So when it's written like this, I don't have this side factored. So I'm going to take out a negative 16. So once I get it to this point, now I have the vertex. So the vertex is going to be negative 5 and 2. This number that's in front, I'm going to set that equal to 4p. It means my p is negative 4. Okay, shh. My p is negative 4. And what that tells me is that if I sketch this, my vertex is negative 5, 2. Bless you. So if this is the vertex, what the p tells me is it tells me which orientation I'm going to have. So from the vertex, the focus, I would count down 4. So if I'm counting down 4, it means that the orientation is it opens down. If the p is positive, we would count up, and the vertex, it would open up then. So this would count down 4. So if I counted down 4 here, if this is negative 5, 2, if I count down 4, what's that point? Negative 5, negative 2. Nothing to memorize. You're just counting. The axis of symmetry, where does the axis of symmetry come from? Comes from the vertex, so that's x equals negative 5. So this is my focus right here. This is the focus point. So I find the directrix. If I count down for the focus, I count up 4 for the directrix. So I would go up 4 this way, and it's a line. So if I go up 4, first of all, which axis does that go through? So this is going to be y equals. So if I go up 4, where is that? It's at 6, so it's at y equals 6. So we're not memorizing anything, we're just counting. And the focal length always comes right here, but it's the absolute value because length can't be negative. So it's 16. And what that means is at the focus, across the focal chord has to be 16. So if it has to be 16, how much would go on each side? So we'd count over 8 and 8, and we'd be able to make our parabola. Okay? So let's try the next one. So x squared, I have x squared. I know it's a parabola. The x is squared, so it's up and down. So what's my p going to be this time? So the focal chord is 8. So I'm going to put negative 8 equal to 4p. It's always equal to 4p. So the negative 2 tells me which way is this opening. It's going to be opening down. So the vertex is 3, 2. So let's go ahead and graph that. We found that p was negative 2. So now I have to find the focus. So from the vertex, I'm counting down 2. So there's my focus right there. What point is that? 2, 0. 3, 0, thanks. So the directrix, I had to count, I count up 2.
Always? Or why?
It's because of the P. So which axis did that go through? Y. And it goes through at y equals 4.
Wait a minute, why did you do the line for that one?
Because the directrix is a line and the focus is a point.
It's just the 3.
And the axis of symmetry? X equals 3. That's where we would be able to fold it in half.
And that's it.
So now I need to graph it. So I'm going to take the focal chord. So at the focus, it has to be 8 wide. So how many on each side? So 1, 2, 3, 4. 1, 2, 3, 4. Thank you. So we're good. Almost. So this is y squared. So this is either right or left. And so I decide which way it opens. I take the 12. What? No, I just paused it. Okay. So which way is this one opening?
Sideways.
Sideways. So, because it's the y squared this time. So if it's y squared, it's right and left. Okay? So, what's the vertex?
No.
Oh, it's 0.
0 and negative 5. So,
I'm tired. Why is it always 12?
it's always the number that's on this side. So, it's going to open right. Really. Keep that to yourself. I cannot have that.
Why? Because it's a positive, right?
Right. Correct. So it opened to the right because the P is positive. If it was negative, it would open to the left. All right? So let's put 1, 2, 3, 4, 5. So we put 0, negative 5. Okay, so listen. This one's opening right and left. So I'm not going to count up and down. I'm going to count right and left. So for the 3, it's positive. So from the vertex, I'm going to count 3 to the right. 1, 2, 3. So that is your focus point right here. So your focus point is 3, negative 5. Remember, the directrix is a line. So from here, I'm going to count back 3, right? 1, 2, 3. So that's the directrix. And axis does it go through? X. So we get x equals -3. So this time, which way does the parabola fold? It folds this way, right? So I'm going to have my axis of symmetry is y equals -5. And the focal chord length is 12, which means how much goes on each side? So, and I count from the focal point. So I'm going to count up 6. 1, 2, 3, 4, 5, 6. And down 6.